Hello, hello everyone. Hello, my name is Christoph. Welcome to Software Mention Academy. This is a series of webinars organized by Software Mention. Today's talk is going to be focused again on animations in React Native, specifically on the new layout animation API for Reanimated library. This is a topic I'm personally very excited about because layout animations are the biggest and most powerful addition to Reanimated since we released new worklet-based API last year as a part of Reanimated 2. And there is no better person to talk about layout animations than Szymon, who was the founding member of Reanimated 2 team and for the past couple of months was involved in building layout animation feature. So I'll give the mic to Szymon, and I think we can be ready to start. So welcome again, and I'm sure you'll enjoy today's talk.
Yeah, I would like to show my screen. Can you also switch the main video to... Yeah, perfect, thanks. Okay, so hello everyone. My name is Szymon Kapała. I'm a software engineer here at Software Mention. Oh, thanks for informing me. Yeah, and I'm really excited today to talk about our latest feature, our animated feature, which are layout animations. We've been working on that feature for, I think, about 8 months right now. Actually, the first prototype I was responsible for the first prototype was working after a week or two, I think. And the rest of the time we devoted to polishing the API and improving the performance. And I hope you also like the API because we are happy about them. Yeah, so let's start the presentation. Okay, so let's first talk about what are the layout animations in the first place, because I'm sure most of you are familiar with that topic, but yeah, I'm sure also that there are some people that are not familiar with that topic, and I want to also talk a few words about what are the layout animations. I prepared a simple definition of layout animation. I think it can really sort things out in your head. So yeah, let's start it. Layout animation is a type of animation that is designed to animate layout changes of a given view. And we can distinguish 3 types of layout animations. The first one is responsible for animating the appearance of the view. So when we set the layout for the first time, we want to animate that change, that transition. The next one is disappearance of the view. It's also a type of layout animation, and we use it when we want to animate when the view is unmounting. And the last one, I think the most important here, is the type of animation that we use to animate all of the layout changes. So we already have a view on the screen and it has its layout, but we want to show another one, and we want to make that transition as smooth as possible. And here in the brackets on the right side, you can see our naming convention, the names that we use in our API in Reanimated. So entering animation, like I said, is responsible for animating the entrance of the view, exiting one for exit of the view, and layout transitions are responsible for animating all of the layout changes. Yeah, and important fact about React components, maybe not all of you are aware of that. Once we remove a component from the component tree, we will never ever will be able to use it again. For example, if you have a conditional component which visibility depends on some states, then once you remove a view from the view hierarchy and add it one more time, that it will be completely different view, and that's important from a perspective of layout animations. And here we can see life cycle of the view. Actually, any view at any moment has to be in one of those 3 states. The first state is obviously the view is not yet displayed, and we have to appear that screen, the component, add it to the component hierarchy. And that's our first transition that we want to animate. The second state is when we already have a view on a screen and it has its layout. And we can change that layout as many times as we want, obviously. And the last transition that we have here is removing the view from the component tree. And layout animations are basically responsible for making all of those transitions as smooth as possible. So in order to improve the user experience, and attractiveness of your screens. Yeah, and here I prepared a very simple screen that we will work on the next few slides. It's basically consists of 2 components. Can you see them? I'm not sure if you can. Please, if anybody can type on a chat if it's visible to you. Oh, okay, perfect. So basically, our example is as follows. We have two components. The first one is just a button, and the second one is our purple box that we operate on, and the one that we want to animate here. So when we tap the button for the first time, the view will appear on the right side. When we tap it one more time, the view changes its layout and is moved from the right side to the left side. And when we tap one more time, it'll be removed from the view hierarchy. So this example is very simple, as simple, I think, as possible, and contains all of those transitions that we want to animate. And I want to give you some examples how layout animations can improve user experience and attractiveness, visual attractiveness of your screens. So let's talk about the first transition. On the left side, we have a entrance of the view without layout animations. The view just appears out of nowhere, and it doesn't look good. On the right side, we have example animation from the React Native library. I'm not sure if you can see it properly. But what's happening here is basically we are sliding that purple box in by the left edge of the screen. And also we transform the frame of that box a little bit, so it looks like it's going pretty fast. The next transition that we can improve with layout animations is layout change. So without layout animations, we are just moving purple box from the right side to the left side. And with layout transition, we use a spring animation to animate the X coordinate of the top left corner, actually the position of our purple box. And the next type, the last one, view removal. And with layout animations. So basically what's happening here is actually a reverse animation to what we saw 2 slides earlier. We are just sliding the animation out. You can believe me that those animations are running at 60 FPS. I think on the new phones even higher. Obviously, limitations here is number of frames that display can render, not our library. And basically what we have here, what's happening here is we are sliding out the view by the right edge of the screen, and we also transform that frame so it looks like it's going fast. And the final comparison, where we have all of the 3 transitions without layout animations, everything is happening instantly, and with layout animations, everything is smooth. Okay. And that's all about the definition of the examples. But we already have layout animations, and they are provided by React Native team. And they're pretty easy to use, as we can see in a moment. We will try to convert our screen that I showed you earlier on the video with layout animations from React Native. But there are some downsides of that library, of that module, and that's why we wanted to create our own layout animations. I will talk about those downsides a bit later. So here's a source code of that example. Can you see the code? I don't think I have any way to zoom it in. I think you can. So it's just a functional component, and it has its state. And its state basically means what layout do you want to currently display at a certain moment in time. For example, if we should show the purple box, or if we should show it on the left side or on the right side. And basically, we are here returning a view container that's covering the full screen, and we have 2 components. The first one is a button that is responsible for increasing the state. And we have another view component, which is a purple box, our purple box here. And we also have one more view component to just change the layout of this purple box. And if the state is equal to 2, then we will display it on the left side of the screen. And if it's and otherwise, we'll display it on the right side of the screen. I think it's this example is pretty easy. And let's add here layout animations from a React Native library. So it's enough to add this line 304. Can you see my mouse on the screen, my cursor? I'm not sure if I can point you some things or it's not visible for you. Yes, you can. Okay. Yeah, so basically, if you want to use layout animations from React Native library, it's enough to call that method, which is just a method from React Native layout animations. And basically what we are doing here, we are telling the React and React Native that you want to animate all of the layout changes that will occur on the next render. And that configuration that we are passing here is only valid until the next render. So we are notifying the React how do we want to animate those layout changes. And here is our configuration. Or actually, we are using here one of the predefined configurations that are exposed by layout animation module itself. And it's enough to just call that method before your state change. And it will work for all of the state changes that are batched together with that change before with that state change that you called that method before. Yeah. So basically, there are some problems about this approach, but we'll talk about it later. First, I want to explain you how it works under the hood. So basically, when you are calling that second method, that's second value, which is a method that's returned by a useState hook, basically you are notifying React Render that you want to do some work on the specific node. In our example, is a screen component. And yeah, React is batching, can batch some stages together. And and all of on the next render, it will apply all of those changes together in one go, in one traversal through the tree, over the tree. And for example, here, let's say we called our configure next method before one of those state changes. And all of those nodes are marked as dirty as a result, and we are waiting for the next render. On the next render, we are changing the layout of this green node. And additionally, as a result of the second state change, we will remove the blue node and we will add another one. So basically, we will have a few layout changes here. The first one is basically the layout change of this green node, and we also have to remove the blue node and add the red one. And React Native will animate all of those state changes. And that configuration that we passed there is valid until the next re-render. Yeah, and what we can change in this configuration, we can pass there what's customizable. So here we can see is a type of a configure next method. We can pass here a callback that will be called when the animation is finished, and we can pass the most important thing, which is a configuration. So we can specify how do you want to handle those transitions, appearance, disappearance, and layout change. And here is a type of that configuration. So basically, we can provide the duration of our animation, and we can provide a specification for all of our layout transition types. So what we can pass here, all of them are optional. So you can provide only one of them, for example. We can override the default duration. We can set a delay of that animation, and we can choose the type of animation that will be used for animating all of those raw properties like layout and like position of the view and dimensions of the view. Also, the property then you can pass here that will be animated together with those layout properties. So you can pass here a spring or a timing or a twin animation. Timing and twin animation are the same, and just different names. And here you can provide some additional properties of the spring animation. So basically, it's not really customizable, and you can only have impact on a few properties of layout animations here. Yeah, and when we already know how to use layout animations from React Native and what the API looks like, let's talk about what's wrong about this approach and what was the reason behind deciding to create our own layout animations module. So the first thing is that layout animations are assigned to our configuration, actually, is assigned to the next render. So all of those changes will be animated together, and we have no control over which component will be animated and which will not. And for example, when we change 3 states, as we do here, all of the layout changes that are caused by those state changes will be animated on the next render. And maybe it's not a problem if you have just one component, because probably we can rewrite it so it's working, even though we will animate all of those state changes. But let's imagine you have a Redux store and you want to update one property there, that one field there that will change a lot of different screens in your application, and you have just no control over which screens and which components will be animated, and that's a problem here, the first one. And yeah, and the reason for that is that React Render is updating all of those state changes together. It's changed since React 18, but with React 18 we still have that problem that some state changes are batched together, and we have no control over which state changes will be animated and which will not. The next problem is that all of those animations are headed entirely on the native side. And because of that, it's really hard to add new animations and give you more possibilities to customize layout animations. And that's why you don't really have a lot of possibilities how your components will be animated, actually their layout transitions. And here is an example of that, what's not possible with React Native. And you may want to use such transitions, such animations. I'm not sure if that's possible for you to see it, but basically we are just transforming several different properties at the same time. And as you saw earlier, you can only provide one property, and with React Native layout animations, and that's not really enough to animate all of those different animations that you can come up with. Another problem is that layout animations from React Native are still experimental for Android, and you shouldn't really use them in your production apps, and that's the problem that we also want to avoid. Yeah, and the last, I think the most important problem about the layout animations from React Native is that you cannot assign different animations for different components. And for example, you may want to set a different animation for different components because they are in completely different subtrees, in completely different contexts, and you just want to use a different animations there, or you can just want to change the delay of those animations based off their position, and that's also not possible currently with layout animations from React Native. And here are some examples that are not possible currently, and maybe you want to implement them. So basically, on the first screen, we are just setting a different delay for different views based on the y coordinate on the screen. And on the second example, we are just choosing a completely different layout animations to animate them in a different way. Yeah, so we already know what's wrong about the layout animations from React Native. Let's talk about how we try to fix those problems. I think we fix them, but we will see what you will say after our webinar. So the first important fact is that we are no longer assigning the animations to the next render, but rather we're assigning animations to the specific view, concrete view, and all of those configurations are valid for the whole period for the whole life of the component, and that's the important thing. The next important fact is that you can only use layout animations with animated component. It shouldn't be a problem for you, because if you want to use a common component, then probably we're already exposing a corresponding animated component in our library. And if you have your own custom native component, or you are using a native component from a library, it's just enough to wrap it with one call of the method that we exposed. It's called create animated component, and we are good to go. Another important aspect is that all of our layout animations are written purely in JavaScript, and they're executed on a UI thread with help of worklets. And that's why it's really easy to add more layout animations. And that's why we expose a lot of predefined animations for you, the most common ones, so you don't need to implement them yourself. And another important fact is that we are not just providing the predefined animations as raw strings, but rather we are providing them as animation builders. so you can modify them as you want. For example, you can set a delay or change the speed of the animation or some other properties. It depends on the kind of the layout animation that you want to modify. Yeah, and another important fact is because we are using actually worklets to implement our predefined animations, it's really easy to add your own custom animations, and we also expose API for you, so you can add your own custom animations whenever you want. And here is how what our API looks like. So basically, when you have animated component, we are just providing those properties. All of them are optional. If you don't provide an animation for a certain property, then we'll just not animate that type of transition. So basically, you are just providing properties like entering for entering animations, exiting for exiting animations, and layout for layout changes. Yeah, and I want to use our layout animations with you. And for that purpose, I prepared this example. It's a participant list, what we have here. So we have just a scroll view that contains a list of participants. And in the bottom, we can see there is a simple text input component and the button. And when you type something there and tap the button, then the participant will appear on the top of the scroll view. And what we want to improve here with our layout animations, the first thing that we want to improve is the appearance of the view. It's not really smooth, it happens instantly. I want to add some features here so it looks better. The second thing here is when we add a new participant, all of the already visible participants will change their layout. They will be pushed down by a height of the new participant. And we also want to animate that change so it doesn't happen instantly. And another thing that we want to animate here is a view removal, so it also looks better for AI. But first, we need to know what's the code of our participant item. Basically, the participant item is just one list item. So what we have here, first we have a view container that's responsible for displaying that, I think, acry background color. Yeah, and we have two additional components. The first one is a name of the participant. The second one is the button that it's able to remove that participant from our list. I think pretty simple example. And let's say we want to add entering animation. So how we can do it? The first step is to replace the native view that you want to animate. In our case, it's a view. And it's very simple to replace because we are already exporting from our animation, from our animated library, corresponding animated component that's just called animated.view. And it's not a problem here. And the second thing is you have to choose a predefined animation. If you want to use a predefined animation, you can also provide your custom one, but I will talk about it later. And you have to provide that animation. And I will also talk about where you can find all of our predefined animations later. So yeah, if you want to animate the entering of the component, it's enough to provide a value for a prop. In our case, it's a light speed in left animation. And yeah, let's see a result of that change. I'm not sure if that's visible. Probably you don't have as many frames per second as I would like to. So basically, you can just believe me that the components are animating themselves when they're added to the view hierarchy, and they are doing it smoothly. And the second thing that we want to improve in our screen is animating layout changes. And for that purpose, it's enough to just provide a layout property. And here we are using the most common layout predefined animations. We have more of them, and we also use a modifier on that animation because it's an animation builder. And our modifier is basically telling that we want to animate all of the layout properties like position on the screen of the view and also the dimensions of the view for spring animation. Actually, we're just using with spring animation that you may know from use animated style, for example, a hook. Yeah, and that's enough to already animate all of the layout changes. As you can see, or maybe you can't, but I will also describe it. When we add a new participant or remove one, the layout of the other participants is animated with our animation. And we use a spring animation for that purpose, as we said it here. And the last thing that we want to improve here is adding exiting animation, and it's very intuitive, I would say, very similar to the entering and to setting entering animation. You just have to provide a proper value for exiting prop. And that's all. And here is the final result. We are animating all of the free transitions. Sorry, I think I may need to go for a charger. Give me a second. Oh, oof. Now it's better. We can continue. Can you hear me? After I probably broke some microphones and headphones, I hope you can hear me. Perfect. Okay, so let's continue. Let's talk now about our predefined animations. So here is a list of actually only types of predefined entering layout animations, because we have several variations for each of them. We have a fade, slide, bounce, light speed. We'll see them in a moment. And what I would like a developer to do, if a developer wants to use our predefined animations, actually go to our documentation page. And that's what I want to show you here, because we have a pretty polished documentation page where you can find, first of all, you can find the instruction how you can use entering animations and the other ones, like I described earlier. And additionally, you can find the whole list of our predefined animations. I hope there will be more pull requests open from the community, and you will also find them here. But right now we have a lot of them. I think it's around 40 or so. And you can find, for its kind, you can find all of the variations of that kind. And you can also find the whole list of the modifiers that are available for a specific type of the animation. And you can also see what they looks like on the video. I'm not sure if that's it will. Oh, sorry. Probably I should. Oh, much better right now. Yeah. So let's see them together. I hope you can see them without any problems. Yeah. So I think here is the best place to find your find the best predefined layout animations for you. And on the left side, you can choose other pages to describe other types of layout animations, for example, exiting ones and layout transition, but we'll talk about them in a moment. Let's check one more entering animation. Give me a second. I'll choose my favorite. Pinwheel. The next one, sorry. Pinwheel animation. Okay. And once again, you can see on our documentation page a description of the animation. You can see variations. Actually, here we have only one type, one variation. And here you can see the whole list of the modifiers. And it can differ between animation types. So it's good to look on our documentation page to find what modifiers you can use for a specific animation. Yeah, let's move on. Yeah, the next type are exiting animations. I think those sets of predefined animations are very similar. I think most of those animations are just a reverse of the entering animations. And once again, you can find the whole description on our documentation page. And layout transition, finally. I actually want to show them. We actually reset when we try to find a proper API for layout animation module. We wanted to research it first to check if other libraries have some interesting solutions, so we can also inspire by them and also apply in our API. And we actually didn't encounter that idea to animate transitions in a different way. Once again, you can see an instruction how you can use the layout transitions animations, and you can find the predefined one. I want to show you a few of them. So the first one is the most basic one, a linear transition. We also have another name for that alias, which is just a layout. I think that's the most common animation. That's also the animation that React Native use by default, but I think we can also configure more things here. So basically, when you are changing the position of the view, you are choosing the shortest path to change the position, and we are just using animation underneath with string or with timing to animate that change. Here you have a spring animation as used for animating all of those layout properties. The next one is sequence transition. I really like that one. Basically, we are first animating the x coordinate and then y coordinate. The next one is just a fading transition. We are hiding the view and displaying it in on the new position of that component. Yeah, I think pretty simple, and I think that one is the most impressive, at least for me. Yeah, so components can jump on your screen. Give me a second. I will try to read some comments on the chat. Okay. And I think the last one, oh, sorry, not the last one. And the next one is curved transition. Basically, we don't choose a shortest path, but instead we just choose a curved way to animate the positions. I'm not sure if that will be visible. I think we should change the duration here so it's more visible. Okay. And the last one is entry-exit transition. So basically, the idea behind it is instead of just animating the transition between the layouts, what we can do first, we can hide the view and appear it in a different way. And basically, the entry-exit transition lets you combine exiting and entering animation. And here's an example. I think we are using a pinwheel in, pinwheel out, actually, to hide the views, and then we use a light speed animation to show them. Yeah, and I think that's all here. Yeah, so we already know what predefined animations are exposed by running the library, and let's talk about how we can customize them. So like I said, we are not just exposing raw strings, but rather we are exposing the whole animations builders. And here's what we can do, because they are not just raw strings. For example, when we want to customize our fade-in animation, here in example, we can, for example, set a delay for that animation. You can change the easing of the with timing animation that is used underneath, and we can also set a callback. You can also use different modifiers, but this is just an example. So we can set a callback that will be triggered after the animation is finished, for example, to change if the button is clickable or not, and things like that. Yeah, and I think the most important thing from that slide is that you can find the whole list of the modifiers that are available for a specific animation on our documentation page. And here are some examples. For example, duration for almost, I think, of our layout animations, you can set the duration of that animation. You can set a delay. You can set the easing if you are using a timing animation. That's the default one. You can set a callback we already talked about, and even you can set a random delay. Yeah, and I think the most common modifier is a springify, and it basically changes the main animation that we are using underneath to animate all of those properties of a component. Yeah, and if you call that modifier, then you can also later modify the configuration of the spring. You can set the damping and mass stiffness. For all of those values, we have corresponding modifiers that you can use them. Yeah, and that's all about predefined animations. Let's talk about the custom animations. Yeah, so the easiest way that we have here to create your own custom animation is to use our keyframe feature. Basically, the idea behind this is that so you are not only providing initial style for the screen for the component and the target one, but you are also providing styles for keyframes for you. I think it's a very common concept that you probably are familiar with it from the web development. So let's talk about a concrete example. So basically here we have two custom transitions. The first one is entering one, and the second one is exiting one. And they are both written with help of a keyframe feature. And here is the source code of that example. And let's go through over that source code. So yeah, it's enough if you want to use that keyframe animation or your custom keyframe animation. It's enough to just provide that variable to the corresponding prop. Yeah. So the most important thing here is that we have to set the duration. If you don't set the duration, I think the default value will be 300 milliseconds. And then you have to provide the styles for all of the keyframes for you. Because it's entering animation and we don't have any previous layout for the view, you have to provide the initial values for your component, the initial styles. And that's why you have to provide the field that's called from. And what you can provide for all of those keyframes. Basically, you can provide all of the UI props, and by UI props, I mean all of the props that doesn't have any impact on the layout. For example, opacity, border radius, transforms, like we have here. And because there's also layout animations, and you have to have a way to animate the layout, you also can animate for layout values like dimensions. You can pass here a width or a height of the view, and you can also animate position of the view on the screen. And for that purpose, you can provide origin X value and origin Y. Origin X is just an X coordinate of top left corner relative to its parent, and the origin Y is a Y coordinate relative to its parent. And that's all. Yeah, I think those two are very intuitive. We are just providing the initial style and the target one. And here we are also providing a styles for frames that are key for us. So this style will be visible, will be set for a screen when the animation progress is equal to 30%, and this one when the animation progress is equal to the half, to 50%. And the Reanimated engine is responsible for interpolating those values and render frames that you are not providing here. And apart from the properties that the style that I talk, you can tell you that you can provide here, you can also provide some options to the Reanimated engine, so it knows how to interpolate those values between the frames. And for example, here we are providing easing. That easing will be used by Reanimated engine to animate those frames that are between the 50% and the target value, target style. Is that clear how the keyframe works, at least for entering animations? The exiting one are very similar, so I think we don't need to go over them. Is it clear? Can somebody type on the chat if that's clear for you? Or if it's not, so I can explain it better. Okay, I think it is. Yeah, and if that's still not enough for you, then you can use the way that we used for implementing our predefined animations. So basically, every our animation is just a worklet. And yeah, let's talk about them separately. I think that will be easier. So let's say we want to create the following animation. So basically, the view is sliding in from the left side, and we also rotate the view at the same time. And after some time, we are changing the border radius. It's not a real example, real world example. Obviously, you don't want such animation, but let's say we want to implement that and see what's the way for doing so. So basically, here's a code. Here's a worklet that when you pass that worklet to the entering prop for your component, then you will see the same effect as you can see here. So what's happening here? You have to provide your own worklet, and that worklet will receive some values from our Reanimated engine when it started. And here you can see what's the type of that object. So basically, what you will get there is it's entering animation. So we want to animate appearance of the view. So basically, what you can get here is the first layout for the view, and your responsibility here is to animate that position, to inform the Reanimated engine how do you want to animate that change. And that worklet is triggered on the UI thread right after the new layout is set. And what's happened later? So your worklet is called with those values. What you can have here, the positions of the view, actually coordinates of top left corner, and they are relative to the parent of your native view. The second thing is dimensions of the view, width and height. Also, you will get absolute position on the screen, so coordinates relative to the screen top left corner, and you will also get the dimensions of the view. And what should you do with those informations? So basically, you have to provide the initial values for your component, because like I said, it's a first layout. We want to animate that, and for that purpose, we have to tell Reanimated engine what animations do we want to use there. But those animations have to have the initial values for them, so they know what are the starting position for them. And for example, here, as you can see, we are animating the x coordinate of the view. It's sliding in from the left side of the screen, and that's why we are setting the initial value for our component to minus width. And yeah, I should also add it to our snippet. Minus width is basically the width here means the width of the whole screen. We could also use here target values dot window width. So basically, we are pushing our component to the left side by the width of the screen, and we are also providing the animation. We are telling Reanimated engine how that value should be animated, how that property should be animated. And basically, we are telling here that we want to use a width timing animation, and it should take 3 seconds. And we want to animate from the minus width to the target values dot origin x, which is the layout that will be set to that specific component. I think it's clear. So it's basically very similar to use animated style hook, but it's called only once right after the layout transition occurs. Okay. Yeah, and that worklet is have to return those two values, initial values and animations, and also you can provide additionally a callback that will be called when the animation is finished. And that's all. Is that clear for you? Should I explain it a bit in a different way, or is it completely clear for you how to create your own custom entering animation? Yeah, it would be helpful if somebody of you could type on the chat. I don't have any response from you. Clear, okay. Yeah, I'm not sure if it's really clear for you or you just want me to move on. Yeah, but let's move on. So the next type of animation that we can create here is exiting animation. And it's an example, the component is just sliding out. Yeah, and that's a very similar case. We also have to create a worklet, but we will get a different values. We will not get the next layout for the view, actually the first one. We will get the last layout of the view because the view is currently removed removed from the native view hierarchy, and we are getting the last layout so we can intercept that event and be responsible for the removal animation. So what we will get here, we also get a layout here, but it's a last layout set for a specific view. And we also have to return here initial values and animations. Actually, you can assign to that value, to initial values, empty object, because if you don't provide a variable, then just we will use a value from the last layout. And actually, those two fields are unnecessary here. Maybe we should remove them fully from the API. Yeah, but if you want to override something just before the animation is started, you can pass those props here. For example, you can change the opacity or the transform. You can set the transform. I think it's also not a good practice because the user will see that something is happening immediately on the screen, and probably we don't want that. And you also have to provide the animations. And yeah, in our case, we want to push the component by the right edge of the screen. And yeah, we are starting from the last layout, and we are just animating the with timing animation, and it will take 3 seconds. I think it's clear. And the last thing is custom layout transition, custom animation that will handle layout transitions. And for that purpose, we also have a worklet, but it's a bit complicated, more complicated. You still get values here, and you have to return animation and initial values, but you are getting actually 2 layouts, not just one, because you need 2 layouts in order to properly handle the transition from the old layout to the new one. And yeah, so here basically you are getting the next layout, and with the corresponding names with a new prefix that stands for before. I think you should change the naming here, but that's how it is right now. For now, yeah. So if you want to get x coordinate of the top left corner of the component from the last layout, it's enough to just call values dot be origin x, and that's all. If you want to get that value from the next layout, it's enough to just call values dot origin x, and that's all. Yeah, and one important thing is that our worklets are called right after UI Manager actually already sets the new layout, and you have to return here new initial values, actually values from a previous layout, so user doesn't see that change immediately on the screen. Yeah, because those values are set right after the our worklet is called, but before the next render, so it's not visible on the screen. Those values that are between the event when the UI Manager sets the new layout and before we set our values. So basically, here we are overwriting those values for the component, and it will happen before the next render. Yeah, and here in our layout transition, basically we're animating first the y coordinate and then x coordinate. How do we do it? The first important thing is that we have to provide the values from the previous layout, so they're overwritten just before user can see it on the screen. And then, yeah, so first we are returning a with timing animation for origin x. So it's animated immediately, and it will take 1 second. Because we know what's the duration of that animation, we can set a delay for x coordinate. That's what we are exactly doing here. We're setting a with delay animation with 1 second delay, and then we will call with timing animation. You can use here all of the animations that are available in the Reanimated library, and you can also write your own custom animations and use them here. So you can use here with delay, with sequence, and all of those things that we have there. Yeah, and that's basically it when it comes to custom layout animations. Yeah, so how do we fix, in our opinion, those problems that I mentioned earlier? So the first downside of the React Native layout animations was that they are working globally, and they are assigned to the next render, not to the specific component. So we have no control over that, which component will be animated and which not. And because we are just providing animation for a certain component, we can just not provide it if you don't want that component to be animated. Actually, the specific transition to be animated for a specific component. So that problem is solved. Another important aspect and the problem of the layout animations from the React Native was that we were not able to provide different animations for different views. And in our API, it's not a problem. We can provide different values for different props for different components. Not a problem at all. And the next disadvantage was that layout animations from React Native are not customizable enough. And we did our best to make it better. So the first thing, we have a lot of predefined animations. The next one, we are using animation builder, so you can even modify them as you want. The next thing, you can create your own custom animations with worklets, and we even provide an easier API for that keyframes feature. Yeah, and that's all. So let's talk about how it works under the hood. So the first thing is that we have to handle registration, because all of our layout animations are executed fully on the UI thread. That's why we need those your configurations on the UI thread in our reanimated JavaScript virtual machine. And for that purpose, right after your component is mounted, we are sending the full configuration to the reanimated JavaScript virtual machine with a tag that corresponds to your component. And that's why we have access to them right away when we want to on the UI thread. Yeah, the next important thing is how the animations are triggered. So basically, when UI manager sets the layout for the views or creates a new one with a new layout, then we are intercepting that new layout, and we are notifying Reanimated by calling notify about layout change method and providing a tag of the component that will be changed in a moment, and the type of that layout transition, if it's entering, exiting, or a layout, and we are providing that layout, and that's why you will later get those values in a worklet. Another example is when the layout is changed, then we have to actually send two layouts, but the situation is very similar, and those values later you can use in your worklet. And yeah, so how do we actually update the native views? So the first case is when the UI manager is changing or setting the new layout for the native view in as a one UI operation block. Then we are intercepting that layout and sending a notification to our reanimated JavaScript virtual machine. And then your worklet is called right away. And then we are able to get initial state from you and apply to that native view as soon as possible. So it's actually happening before the next render. Yeah, and the second case when the view properties can be modified are when there's still ongoing animation for your component, and Reanimated just is notified about the new frame and is able to get the current result for your component. And that's all. Maybe I should also mention one important fact. Let me go back to that. So basically, the animation is finished when the last animation from this list is finished. That's also important to mention. Yeah, and that's all. I didn't want to go deep here. And let's talk about our future plans, our ideas, how we can also use those layout animations. So we have a lot of predefined animations right now, and we thought we can make use of them also in different areas. And we thought that it will be really a good idea to also use them for screen transitions, and that's what we want to do. We want to add our predefined animations to screens or even to React navigation, so you can use them to create your own layout, your own screen transitions, and also to use already predefined ones for animating, exiting, and entering of your screen. The second idea is to provide the API for reparenting and hero animations. So basically, if you want to move your component between two subtrees, we want also animate that change smoothly. So we want to match the old layout of the old component with the new layout of the new component and animate that change as it's just a layout change of that component. Yeah, and here is, I think, a better visual representation of that. So let's say we want to animate our blue node, and we just want to attach it to a different parent. And after that change, obviously, the layout can change of that component, and probably will. And we want to add API that will just match those two native views and animate that layout change as just a new layout set for the old node. So that's our next idea. And the last one that actually I don't have a slide about it here is is we want to give you a possibility to run our predefined animations whenever you want, not only when one of those layout transition happens. And that's what we will be probably working on later. Yeah, and that's all what I prepared for today, and I'm ready here to answer your questions if you have one. Do we have any questions? Give me a second. Oh, sorry. I was just informed that we have here a section that I probably should check it out. Is there any limitation on Android? No, our layout animators are fully functional on Android and on iOS. Actually, they're right now in beta, but probably in a week or two, they will be released as a stable API. We have some things that we need to work on. For example, cooperation between their layout animators from React Native and between our layout animations, because we are actually, our implementation depends a little bit on the native implementation of layout animations from React Native. And yeah, we want to make sure that we will not broke down some behaviors that you already may have in your applications. But I think that we already fixed most of the problems that were there. And yeah, I think they are fully functional on Android. And the next question. Are you using it in production already? I have no idea if somebody is already using it in production. I think that's not a good practice to use API that's it's not released as stable. So probably, I hope you are not using it on production already. I think it will be safe within 2 weeks or so. At React Native Europe, Joshua said they've been working on layout animations using Fabric. How does they differ from this one? So basically, I read the whole code of layout animations that are written in Fabric. The one and really important difference between those two is that from Fabric, we will have just one implementation of layout animations that's written fully in C++, and that's really good news because there's less code that can be budgy here. And yeah, and I think that's the most important thing. But the API will be the same, and they will suffer the same problems that I mentioned here on this presentation. But what I actually hope that we will port our layout animations to the Fabric, and I think it's actually easy to do, but I have to research that area more. Can we use layout animation on flat list to sort items? You can use layout animation on scroll view. There are some problems with flat list. Like I said on our webinar, you have to use animated components in order to animate your views. And the problem with flat list is that flat list is actually wrapping all of your items in a view component. That's why it's not really possible right now. The only problem that we have right now is that we want to change the one line in flat list implementation. We want to use animated.view instead of the view, and that's the only problem. But it's a really easy problem to patch, and I think we will create a pull request to React Native to fix that problem. Can we use this for shared element transition? Not right now. Right now, it's not possible. We will probably add it soon, but I don't know yet when. Will be there some physics support between components? I actually don't understand that question. If you could try to put in another words, that would be easier for me. When will this be available as stable form production? I think Krzysztof Piaskowy is the best person to answer that question, because right now he's responsible for a stable release of it. I think I think we can expect to be available this month, but we will see what will happen. For variables like b height and b width, yeah, for sure. The naming can be improved here. It just wasn't the biggest problem that we had, and that's why we didn't focus on that. But yeah, for sure, we should change the naming here. I think it will be even better to expose two fields in that values object, last layout and the next layout, so you can separate them more easily. Yeah, I think we will. Yeah, that's exactly what we want to do. We want to create alternative for React Native shared elements, but actually we will do more than that, because we know we will also provide API for reparenting. That's something a bit stronger than hero animations, because you can have the same component but in a different subtree. That's something that's not currently possible with React Native shared elements. Can we have code snippets in the docs for the animation video examples? All of those videos are have been captured. Sorry, they are actually recordings of our Reanimated example app, and you can find all of those codes just in our repository. Maybe somebody from our team can drop you a link to our Reanimated example app. The next big milestone, I think the next will be porting Reanimated to Fabric. It's partially done. We have some problems that we are working on, but I think that will be the next big step, and probably the most logical, I would say, because I think eventually we will all move to the new React Native architecture. That's why I think the next step should be porting Reanimated to the Fabric. About the physics. So imagine we implemented a rectangular view that moving in some sort of box. With physics, you may be able to restrict animation inside the box. Layout images are not really working together with gestures that are triggered by renders. So I don't think we can use them to restrict the area where the view can be tracked or things like that. I'm not sure if that's what you are asking about, but that's not a part of our code that's responsible for gestures. I think that was the last question. Okay, so thank you very much for listening, and that's all I prepared for today.